It's live?
Yes.
All right.
Yeah.
So, hello everyone.
Hey,
I'm Rahul and I'm the co founder of Punar. Now, let me start by introducing myself. On a related note, I am also a VITN, also a member of, was a member of IEEE SPS. And right, so let's talk about a bit of the startup that I am in. So, our startup creates robotic solutions for physiotherapy. Now, in India, till now, when you talk about physiotherapy, what do you see? What do you think of? The first thing that you can think of is, monotonous devices, some gym equipments, or very monotonous things. You definitely don't think of robots when you think of physiotherapy. But things are actually changing. In US, Europe, people are using robotic rehabilitation. For the past 5 years, there have been numerous papers that show how robotic rehabilitation is great in treating patients quickly and more effectively. But in India, what people think of is, because building robots is very time complex and difficult and even expensive method, why not we just keep using what we are using, right? So what happens is people generally import the devices, and people generally think that it is expensive. So in some physiotherapy centers, like in Mumbai, there's a Ambani hospital or something. Then there is some David Health in Bangalore. So there are some posh areas where these devices are kept, robotic and data-driven devices, and are not accessible to people. Now you and I, we actually order a car from Uber, right? We do Uber on a daily basis, or Ola. We actually order our food from Swiggy. We like to have things, and can actually afford, mid-tier. We are not just it should not be that we should be paying a lot of money to get that. You get what I'm saying? Now let's say, think of 10 years ago. What used to happen 10 years ago was, you couldn't book a cab if you're not rich. You couldn't book a cab from, let's say, your marketplace to your home. It would be very expensive, but now you can actually do that in 90 rupees, right? 100 or 120 rupees. You can book a big cab for that. So, how the technology is getting brought to the mid sector is an interesting thing. And that's what we are working. We are trying to build affordable robotic solutions which is accessible to all. Now, why am I giving this session is because 2 years ago I graduated, right? No surprise in that. I graduated, and when I actually wanted to do a startup, it was a robotic field, and I was very interested. I wanted to see what can be done. But the moment first Signal came into my life, it I couldn't use any academic stuff. I knew FIR filters, I knew Butterworth filters, I knew a lot of things, boring things even. I knew it, but I couldn't use them. So in this presentation, I'm going to talk about what signals are, what type of signals you can actually expect in some real life scenarios. Why isn't your academics going to help you? Why common sense is going to help you? And how do you move from that? So you can learn, it's common knowledge, right? You can learn anytime you want, even at 28, 29, 30, 35, 70 years old. But common sense is one thing that you have to build, even if you don't have, right? So that's what I'm going to let you understand. How did I go through this? And let's be very sure, I'm not an expert in this. I don't have a PhD in it. This session is going to be my experience over signal processing. And I think this is fit for IEEE SPS because, come on, that's their perfect domain. So without further ado, I would love to start. Is there anything anyone wants to add? It's
no, so we
buffering.
can carry on with our session.
All
Is
right.
it?
Okay. No, no, it's not. As in, there was a comment saying it's buffering. So,
Okay.
all right. I think it's not. So let's move forward. Now, what is signal analysis? What do you do? When you say you're doing a signal analysis, there are 3 steps, right? You first acquire a signal through something, then you process it if you need to, then you package it and ship it, right? That's the 3 step of signal analysis. Boring, but let's try to make it interesting. Now, in our company, if you see, we have a robotic system where whatever you do from one hand gets translated to other hand. Now, there are again more complex things that are happening on the affected hand, but this is the same thing, right? You take a movement from one hand and then you translate to the other hand, right? Simple enough. All right. So for capturing movements, one of the techniques we use is bend sensor. You all have seen a flex sensor, right? Right. So what flex sensor does is when you bend the flex sensor, the resistance increases, which with the help of a voltage divider bias, you can convert into a voltage, right? Now that voltage, that analog voltage is your signal. I'm hearing a bit of a noise, I think. I don't know from where.
Akash.
All right. Thanks, Akash. All right. So that's what. So that analog voltage is my signal. Now I'll show you in the next slide. I'll quickly go back and I'll go forward and go back again. I wanted to show you how a signal looks like. Like 1 second. Oh, I got it. Yes. Can you see on your right side? Right. So what happens is the moment you move your hands, the voltage value increases, and when you release your hands, the voltage value decreases. Now, isn't it supposed to be a pure sine wave, increasing, decreasing? But it does not, because there are noise. Even there are vibration in the sensors. Your fingers vibrate a bit, which will give it micro vibrations, and then there are other things that you generally don't know. It's a physical thing that's happening, so you cannot get rid of natural noise artificially, as in. So how do you handle with it? So this is the kind of thing. Now what happened is, when I'm moving this hand, if the values are like this, guess what will happen to the actuators, the thing which is driving the other hand? It will go crazy because it doesn't know what's happening. It will move forward because of the noise. It will move forward. It will move backward. And when you try to stop it at a place, it will jitter, right? So this was happening, and this is a very good example of signal processing. Very simple example of signal processing, but very useful. Now let me get back to my slide. All right. So you acquire some signal. Now, as you saw, there was a lot of noise in it. So we need to process, right? In this case, signal processing is just noise removal. Then we package it. Now, packaging a solution means generally either making a .exe file out of it, or making an API out of it, or making a software out of it, something like that. So this is the last part. What we are interested in is processing. Now, in analog side, you create a gain because suppose the voltage values are low, you create a gain, you increase the voltage value. Now you have to clean it. What does cleaning means? Suppose you don't have a lot of good values. Suppose it's fluctuating a lot. You want to just remove the values which are beyond normal. Sometimes when you use Arduino, there are times when you get negative integers even when you are not intending to. Some zeros, some negative integers, some characters that generally are not understandable, like it's not UTF-8. What happens when those characters come? What is your program supposed to do? It is supposed to ignore that. So those are cleaning, basic cleaning. Then we digitize it. No, digitization is, I'll explain. So I got a voltage signal, right, from flex sensors. Till that part, is it clear? Do you have any questions? Anyone? All right. Please do ask in the comments if you have. Now, suppose you got this voltage signal. Now, what our part is to get an ADC. What's an ADC? Analog to digital converter, right? So we use a 16-bit ADC to give us a digital value. That's called digitization. Do we take care of it? No. We buy an IC from Texas Instrument that takes care of it. Our part is to clean the data. It's from the digital side. Now, how do you clean on the digital side? Hello, Justin. Somebody commented. All right. How do you clean? So this is the session that I'm going to take. All right. For the purpose of it, I'm going to use Python. Do you know, in my company, I always use Python. Microcontroller, Python. Server side, Python. Front end, Python. ML, Python. AI, Python. Everything Python. We even used Python for GUI, but then obviously we had to shift to Android, native Android. But yeah, Python is very flexible. Why do we use Python? You have been taught MATLAB, R, things like that, right? Why Python? Well, obviously it's free, so nobody can come and sue you if you're using a cracked version. It's flexible, it's high level language. There are many open source libraries on it. Plus, it has a very good GUI, graphic user interface. You can easily plot a graph like MATLAB. You can plot it on Matplotlib. There are very easy sets, numbers, arrays, operations. And then obviously the best thing is Stack Overflow. Great community, man. Anything you want, you will obviously get it. So that's the reason we use Python, and everyone should when you are trying to do a startup. Now, what are we trying to do? We are trying to read with Python. How do you read that? There are some C++ APIs that we use, or PyUSB, sockets, PyAudio, PySerial. How many of you have heard PySerial? Right? When you convert from Arduino to Raspberry Pi or something, we use PySerial. It's a simple thing that you can actually transfer from one device to another. Now, when you have to clean it, what do you use? You use SciPy, NumPy, things like that. Even if you want to use if loop, for loop, just to clean it up, you can actually do it, right? For visualization, we have great Matplotlib, which I'm going to use now. PySide, I think very few people have used PySide, which is PyQt now. And PyQt Graph, everyone uses it now. For compilation, we use PyInstaller. As XLWT, we don't use, it's an old technology, but SQL is basically converting everything into Excel files. Now, this is why we use Python. Now, let's move on to the graph that I already showed you. This is a graph that I got, and let's see how can we improve it. Now, the big problem is memory constrained devices. Why am I saying this? Is because the moment I showed you that graph, most of you would say, come on, it's simple, digital filters, some FIR, you can use some Butterworth, right? Obviously noise will have high frequency, you have to use a normal low pass filter. Why do you go digitalization? You can actually make a hardware filter, that's much faster. I'm going to show you why not hardware, but before I want to show you why this is a very big problem. All those signal noise filtering algorithms that you have learned, and that are very interesting, you cannot actually use it in an Arduino, let alone with the chip that we are using. The chip that we're using is A85. How many of you have heard about A85? Please do comment. One? Yes. I want one. I think somebody. A85, it's an Arduino based controller. Small, 8 pins package, very small. Now imagine if I want to run a noise algorithm on it. Damn, it would be difficult, isn't it? So I cannot go to that part, and I still need to denoise it. How to do it? All right. So let me think about hardware filters. Why not hardware filters? So this is what I did just before this session. I took one of the graph, which was very noisy. This is a raw value that I got, and I did a spectrum analysis, right? The moment I did, you can see the spectrum analysis here. There are a lot of low pass, low frequency noise, low frequency signal. Then there are nothing, and then there is a high frequency noise, right? High frequency signal, which has to be noise. Looks very simple, right? You can actually design low pass filter from 0 to, let's say, 20 hertz and get over with it. So let's see. I did about 200 hertz. Here you can see, so that it gets into this window, and then this is my filter frequency response, and then the moment I used this frequency response on my signal, I got this. Is it looking better with any angle? Is it? No, right? Why did that happen? My beautiful signal, how did it become that? I did all the correct things, right? Common sense. I have to put a low pass filter. And the moment I did, I got this. Can anyone interrupt me and say why? Just guess. Just one, please. Gosh, let's see. Any guesses? Lakshmi, any guesses?
No, sir, I don't have any
No, sir.
guess.
All right. Very simple. Can you predict the motion of the finger? How fast or how slow it's moving? No, right? You cannot, because I am going to. You cannot predict what I am going to do. I can start slow and make it fast. I can start fast and make it slow. For patients, which our devices are primarily for, their hands are very clumsy. So, human motion, when you cannot predict, how are you going to put a filter on it? Maybe my high frequency things are actual signal. Maybe the low frequency things are signal. Who's to know? This is why hardware filters cannot work here. Now, what are the advanced, okay, techniques, latency and all? Let's think, take this like, now what steps did I take? I did sampling, buffering, and averaging. Why did I do that, and what are the steps? I'll shift my screen from this to my Python code, which will explain this. One second. Meanwhile, if anyone has anything to pitch in, I don't want this session to be boring. If anyone is not understanding, please do ask. All right. So fine. Nice. Let's move ahead. Can you guys see my screen? Not yet.
Not yet, sir.
It's supposed to be. It's there. I'm seeing all the options for stop sharing and all. Let's stop and start again. Let's see. Yeah, great session. Very informative. I have not yet started yet. I'm just relating to you guys because coming from a second year, third year, it's very difficult to. Well, it's very difficult to make signal processing interesting. I was there, believe me. So I just wanted to show something. Come on, it's not showing. I have no idea why it's not. Yes.
Yeah, now it's sharing.
All right. So, few libraries, no need to worry about it. My files, all the performance indexes are basically the file that we receive from our servers. These are actual patient files. Some basic operations. I'm not going to go through this just to go through this. Okay, let me go through it. This is the type of file, and this is what I am doing in order to filter up the values. Okay, and make sure it is easily accessible. So after whatever I did, I got values. So each of these 5 values are from 5 fingers, Y1 thumb, index, middle, and so on. So I've got list, right? Uh, if I start plotting it, obviously it will be on a different window. You won't be able to see it. So I'm going to go through the code a little bit. Now, what do I mean by sampling when I say? Uh, because a general question would be, isn't the signal sampled? It's a digitized signal, right? You're getting it from ADC, so it must be sampled. Yeah, it was sampled, but think about it. If you're getting if you are having 1000 values that you're plotting and it is a lot of noise, wouldn't decreasing values, let's say I'm taking only alternative values, wouldn't that smoothen out the curve a bit, right? So that's sampling and we are going to use it. So what we do is we are trying to take every 5 values. You can actually very easily see this code, right? If count percentage sample is equal to 0. So every time count increases, let's say 1 is not 1 modulus 5 is not 0, 2 modulus 5 is not 0, 3, 4, 5 modulus 5 is 0. So every fifth value I'm going to do, and every fifth value I'm going to uh, pop one element out from my database and I'm going to take it. So let's say this is my new value, this was my old value, and I'll do some operations. Let's say this operation is just averaging it out, shifting the old values and putting it, obviously increasing the count. This I'll ask later, but till here it's fine, right? So I'm increasing the count and going over the process. What are these code doing? These code are simply to select every fifth value as we are going and create a list out of it. So now the thing is, I cannot show you actual real values, right? Because come on, I don't have the device right now. All I have is a list. So I wanted to give you an idea of how the real-time signal works and why is it very difficult. So I'm just taking out from a old list and making us believe that it's real. So see, y1 was an already available list. What I'm doing is every time I'm popping out one element and I am thinking that, okay, this is the value that I've received and I'm going to do operations in that. All right. So that's my trick. And I just pop out few values, every fifth value, and everything else is great. Now, can you tell me why I have this part of the code? If count is greater than 100, should be equal to 0. Why am I resetting count? I don't need to. Even after 100, modulus 5 will be the same thing. Any guesses? Somebody said screen is not clear. It is VS Code. Yes, it is VS Code. No, it's not PyCharm.
And someone asked, why are you sampling every fifth value?
Oh, I
So,
can sample every sixth value, seventh value, eighth value. It's just a random trick. So what we do is, I tried 10th value. It's just hit and try. I did fifth, I did sixth, 10th. So the at the value which I was comfortable enough and it was good enough, I just took that. No rocket science behind it. So yeah. All right. So it is VS Code and this is why fifth value. Now, can you tell me why am I writing this 2 lines? Why am I resetting count? 100, 100, 1, 2, 3, 4, 5. It should work the same. Why do I need to? Just a bit guess. Come on. Any guess? Any guess? I'm going to pick only 2 names that I can see on my screen. Akash and Lakshmi.
so probably because like if it's greater than 100, it should reset or something.
No, no. So
No?
I think, suppose it is greater than 100. Right? If I don't put a hard stop on it, and if I don't count between 0 to 100, what will happen? This count 100 keeps increasing,
To
Sir,
101 to
it might lead to infinite loop, sir.
not
Like
infinite to infinite number.
infinite number, sir.
the
Yes,
number.
yes. Hi, who is talking? I want to know the
Arul,
name.
sir. Arul.
Arul.
Arul Dash.
Right. You were on the right path. See, it goes to infinite, or not even infinite. If it becomes such big number that my microcontroller, a 12-bit microcontroller, is not able to take in, then what's the use, right? It will eventually. Yes, somebody said because of the size issue. Allah. Thanks. Exactly right. This is why I reset every 100 times. So that this integer is not big enough so that it rolls down and my whole program crashes. Because again, why? It is a memory constrained device. Alright. So let's move. I print the new thing. I'll print something that's for me. I just printed and the same printed thing I showed you guys. Uh, yeah, I think I did. Alright, I sampled. I did an average. Instead of buffering, I did an average. Oh, and that's about it. Yeah, this was the basic simple thing, right? Now I'm going to show you, even after doing this simple thing, what my result was. Um, can I run my screen and show you that? Let's see. Right. Can you see this? Let me see if you can see. No, you can't because it's a new window. Let me stop sharing and share a new window. Okay. Please do come quickly. You have to wait for that it to get ready. Hmm. Yes, it can. All right. Okay, so you can see the first graph. It's a bit thicker, isn't it? And the
Yes.
second graph is a bit thinner. This is what I was trying to say. Now, if you are not able to see this, I'll zoom a bit. Let's say this part. And the same part I'll zoom here. See this? Far less. See, if you can see this part, sorry, this part. If I zoom it, it will go off. And the same thing here, this part. See how small it is? That
Yeah.
reduces jerk. But I think there is still jerk here. Let's see. The value here you can see in the bottom right, the value is 6970 and the top is 7038. About 100. Yeah, right. And I cannot reduce that because the moment I do, I lose my signal. But it's good enough. And I'll tell you how to reduce that in fact, because see, even if now you are trying to move an actuator, what will happen is it will jitter. It will not be a smooth experience. What we're trying to build is a very smooth experience for the patient. So this is what we have received till now. Now, what is the next step, which I couldn't show here? That's why my equation did not have. I'll share my Arduino screen for after some time. That will be very clear. Let's take a bunch of values. I saw that on. Please put your attention to the bottom right. The Y value is 6,600 something, right? And the top part is 6,700. So I know about 100 range, 100 is the range, which I need to not consider, kind of. So it's like a buffer, right? If I get any number, if suppose I got a number, right? And if the next number is not greater than 100, I don't consider it as a value, right? All right. So this is what I'll do in my screen. One second. I'll share my Arduino screen. And as it goes, it will take a bit time. Now we wait. Is there any questions? The variable data type size will go out of range at some time. Yes, yes, because when you consider int or long, it has a fixed size. And that size it reduces. So it will roll off. Okay, wait for me adding code. My internet is good. I don't know why this is happening. Yes, now we have. All right. So let's define the buffer. For here, I have a buffer of 150. All right. So what I do is when I have to equate flex sensor to the actuators, right? This is what I'm trying to move. Suppose the bend is at this level. I want my actuators to drive it to this. So I'm going to have a condition. And that condition is something like this. If the flex sensors is less than actuator, go backward. If the flex sensor is greater than, flex reading is greater than actuator, go forward. It should be this, right? But instead of this, it is minus a buffer and it is plus a buffer. You see what's happening? For each flex value, my actuator stops if it's in the range of -2, -100 to +100, -150 to +150, about 300. And that was the exact noise that we were getting, right? So when the actuator comes to that point, it does not react until unless it has received a higher number. So even when you are stopping mid point somewhere, the actuator doesn't jitter. It stays at a point. Is this sense? Is this making sense to you? Right. This is what I think is a small step. You don't have to share resources. The memory constraint devices itself are good enough for this. It's a simple less than greater than equation, right? So it's good enough. Now, what I'm going to do is share my screen and wait for 2 minutes because that's customary here. So that's what next. What I'm going to show is, oh come on, it's just one slide now. All right, now that was good enough, but we actually wanted something else. We wanted it to be much smoother, and this is why our device is much smoother than our competition. So there is a patented algo. I'll try to explain the common sense behind it, and then just show you how that what that algo looks like in reality. So I'll stop sharing and I'll share a different screen. Wait for customary 2 minutes. Yeah. Okay. Okay. Suppose you got a value. Let's say x1. You are happy with it, right? You got some value. Now let's say you got some other value, x2, and you said, I don't want this x2 right now. I want averaged out value. Simple enough, right? I do x1 plus x2 by 2, right? Let's see for the next part. We get x3, x1 plus x2 plus x3 by 3, right? No, wrong. This should not happen. Why? Because x3 should be equal to, sorry, 1 second. This should be x2 dash. X3 should be equal to whatever value we have received, x2 dash, plus the new value divided by 2. Don't mind my handwriting. I'm not writing with a pen but a finger. Okay. So, which is nothing but equal to x1. Okay, this is wrong. I don't have to be confused with this. X1 plus x2 by 2 plus x3, right, which is equal to x1 plus 2x3 plus x2 by 2, something like this. This is something what we were doing. Remember in the code, right? This is what we were doing. We'll always add whatever we have received, like whatever we have calculated, to the next one. Now, this is called averaging out. But a better way is simple moving average. How many of you know about simple moving average? Anyone?
No, sir.
Simple moving average is when you average out things with a window size as you go on, right? So I'll give you a very simple example, which is called cumulative moving average. What we do is, suppose we have a list x1, x2, x3, and so on till xn. And I have to average it out. So what I do is, I'll say for the first two, I'll say x1 plus x2 by 2. Damn my handwriting. I'll switch off my camera so that I get enough space to write.
Sir, is it like it takes different averages at different parts of the data set, and makes the
Yep, that's exactly what I'm talking. But I'll show you the problem when you use a simple moving average. Exactly,
okay.
that's what the thing that you're talking about. That's the exact thing. Uh, alright, 1 second. I'll have to switch my camera off. Is it off? Yeah, it's off. All right. So this will be x1 plus x2 by 2. Next would be x1 plus x2. It's not better. Plus x3 by 3, right? And if we go on, it should be x1 plus x2 plus so on till xn by n. You average out in this way. The numbers that you got, you write it down in a list, then you plot it, and you'll have much smoother values. Of course, I had Python code for this, but for some reason I couldn't find it now. But you got the idea, right? It's very simple. It has to be a smoother value. Because I showed you, if averaging out two values was a bit smoother, averaging out like this will always be more smoother, right? Now the problem is we always don't have all the numbers, right? We cannot know what is xn because the signal is still coming. There is something called reiteration. Sorry, reiteration over it. What we do is, once we got this number, we actually do it again with the numbers that we have received. We actually do the same moving filter again. We average that out, then we average that out. Eventually, we'll get a smooth value. But this is only possible when we have all the values. When you don't know the next value, how do you do it? One more thing. For this to happen, you have to store all the previous values, right? If you want to calculate for xn, you need to have all the values from x1 to xn. It looks easy, but in our case, xn reaches up to 7,000, 10,000, 1 lakh because the patient is doing continuously for 15 or 20 minutes. Do you want to store 7,000 values on a 8-bit microcontroller or even a 12-bit microcontroller? 256 KB? You cannot, right? If you can't store that there, how are you going to calculate moving averages? Very difficult. This is what I'm going to solve. A small, mathematical stuff that I'm going to show. Very quickly, you'll be able to realize what's happening. All right. So let's see this. X1. Okay, fine. X1 is allowed. Let's see X2. When I get an X2, I say, dude, I don't want you here. I want x1 plus x2 by 2 to be my new x2, which I'll represent by x2 dash. Then my x3 comes, and I say, dude, I don't want you. I want x1. What happened? Something happened. Are you able to see my screen?
Yes, sir.
Yes, yes, yes.
Yes, sir, it's visible.
I'm going to calculate x1 dash, which is basically x2 dash, x3 dash. Sorry, not x3 dash. X3 what I have received by 3. And so on. If I move forward, I would want I would say no x4. I don't want you. I want x1 dash. I want x2 dash. I want x3 dash. I want x4 by 4. Right? This is what I actually want. Now let's do a small calculation here. Let's just calculate it out. So this is x1 plus, instead of x2 dash, what I can write, x1 plus x2 by 2 plus x3 divided by 3, which is equal to what's 2x1 plus x1 is 3x1. Got it? 2x1, 2x1 plus x1 is 3x1 plus x2 plus x2 x3 by 2 into 3. Looks boring? No, it's very interesting. Some after just two or three iterations, you'll get to realize what's actually happening. Let's try to have this. When you have this, it's x1 plus now x2 again. I have to write as x1 plus x2 upon 2 plus whatever I had here x3 as 3x1 plus x2 plus 2x3 divided by 2 into 3 whole divided by 4, right? Now when you calculate this, I'm not going to calculate the whole of it, but can you see the fraction here? This will actually go here, right? Cross multiplication, and the whole denominator becomes 2 into 3. So the whole denominator actually becomes, what does it become? 2 into 3 into 4. Is it an eye-opening moment till now? Or do you want me to do hard work and calculate everything? I can do that. But I think it is fairly visible right now that you are getting something like a factorial, right? The fourth one is a 4 factorial. The fifth one would be 5 factorial and things like that. So there is a pattern which you can actually find out. Now with this pattern, there were some modifications that we had to do. And by the end of it, what we got is, I will increase the size. I have just copy pasted it from my blackboard. Can you see this? This is the final algorithm that we got with acute intake, and this is the interesting part. Here I need to save only one value, and everything else I can just have it from the list. Now the thing is, this creates a real-time simple moving average, and I don't need to have all the data values. Got it? Oh, I was trying to show you that hello, sorry, am I audible now?
Yes, sir. Now you're audible.
All right. So, I understand this has been almost 1 hour, and the reason I wanted to have this one discuss this in 1 hour is because it's not always academics that will help you, right? And wasn't everything I did here, till the algorithm that I built, wasn't everything just simple common sense? The
Yes, sir.
intuition to work towards a problem, in signal processing is much more helpful than just reading out some formulas and trying to apply it. This is the point that I wanted to make, and I think I've been successful in making it. It's on you if you say so. All right, so I would accept any questions if you have.
Yes, sir.
Yes.
Jam, I
You just
was. There is no question. I made you speechless. Come on, it was not that good.
no, sir. It was really wonderful. You
Yes, sir.
actually,
Very well said.
made a very difficult concept into something simple. So we actually understood it very clearly. It was really great.
Thanks. All right. Oh, I have a question. What do you think about the
Yeah.
growth of IT as a sector in India? Did you copy paste the question? Oh, that's a good question actually. Uh, yes, everything. Right now, you see what are you hearing every day? You're hearing about 5G. You're hearing mostly you're hearing about internet and how internet is bringing everything closer. Things which are not internet enabled will eventually become internet enabled. Why not start with medical devices? And therein we are. Yes, 4 5 years too much. Around 3 4 years you can see the thing. Right now your education is internet based. What about that? 3 years ago it would have been 4 years ago it would have been a nightmare. When you say you are doing an BTech degree online, was it even imaginable? But this happened. So internet is going to come in every sector. Yeah. Uh, you know, building. So the question is, can microcontrollers be custom built and encoded? Microcontrollers can be, but do you want to take the pain of doing it, or do you want to just get a microcontroller that fits your requirement? Because most often than not, you can actually get the microcontrollers pre-built. But if you're interested in it, we actually have talked to a company. They are in Singapore and they will build custom devices for small chips. I don't remember the exact name of it, but they actually build the chips for OnePlus band that you have seen and OnePlus watches. All right, so you are studying actually IoT from Velour. Oh, come on, that's very good. All right, so Ayush, if that's the thing, yes, IoT is a very good sector. There are very different sectors in IoT itself. You can be an IoT expert in autonomous society. I'm not talking about chapter. Autonomous society is actually a society that is building electric cars, that is actually helping in build electric cars and all of that. And most of the cars, whether electric or not, they are trying to get into IoT. So that's one thing. Then there are other medical devices. There are shit devices that can use IoT. Man. You can actually work on Samsung if you're very good in IoT. Uh, when can we do it cheap and to our needs? Hmm. When can we do IoT cheap to our needs? It's very cheap now. If you think about it, a small ESP32, that's a basic IoT chip, I think, that comes about 400 500 rupees a pop. It's
Sir, actually, the question was with the microcontrollers. When you can do it cheap and to our custom needs, will it work out? As you said, no, like we take up the pain of making it customly. When we want it designed to our needs, will it be more benefit?
no,
Like,
it would be very expensive. You know why it would be expensive? Because what you're not thinking is the manufacturer of the controller has to create that controller, right? And to manufacture that controller, he cannot do it one a piece. They are generally 1,000 a piece, 10,000 a piece. And then there are molds which actually creates it. If you are in electronics third year, you will learn about PLSI, and there you will see how layering and everything works. So you cannot build one. You can. I mean, it's going to be very expensive again. But those controllers, when you want to build a controller, it gets expensive because it's always a batch thing. Am I making sense?
yes, sir.
Yeah. So this is the reason why the ICs like at Mega and all, they're very cheap because everyone uses it, right? So many people uses it. So when they use it, when there is a lot of IC in the marketplace where there is a lot of need for it, the price reduces, and if there is no need, the price increases. Likewise, we were using ADS 1115, which is a very common ADC. If you go to Ganesh Electronics, if you're in VIT, I think you would go to someday. And when you go to there, when you say an ADC, they'll give you ADS 1115. Very simple I2C based analog to digital converter. But for certain things, we wanted ADS 1118. Same company, Texas Instrument, making same type of ICs, same pin package. One is very cheap, around 200 rupees, and the other is very expensive, about 640 650 rupees. See, the difference is because nobody wants 1118 among other things, but there is less requirement of that. It's a bit complex for newbie. It's not very easy to do. That's the reason. All right, I have got a lot of questions here. Career options in wearable technology, very good. Uh, so wearable technology is slightly towards more electronics. Why am I saying this? Is because your current limitations is about 100 milliamps. If you're building a wearable technology, make sure that your current requirement for the whole device is less than 100 milliamps. Because if it's not, they won't categorize you as a wearable technology, and you'll have to stop the device. That's a hard lesson for us. So, um, I don't know. Can you please highlight that question, Alap? I want to ask related to coding part. I know Python, I know, but I know C, C++, Java, all for creating projects. What's the opinion completely shift to Python? All right, so Python is easy. That's one thing. But if you know C, C++, Java, it's good enough. Uh, do you know compiler designing or some cross compiler stuff? Because when you know more than one language, there is a tendency that for some stuff you would like that language a bit more. Make sense? Because suppose if you're doing controllers in C++ and maybe networking in JavaScript, or maybe Java if you are old enough. So if you're doing that, suppose if you have an IoT project, you tend to do the Wi-Fi part in Java or JavaScript, and you tend to do the controller part in C++. Now, when you try to do that, you want to find a cross compiler or something like C Python that you use, some C libraries in Python, or maybe some JavaScript library in C++, something like that, and that becomes a bit hectic. Some autonomous company do it, and that's what my point would be. So yeah, Python makes it easier because it can do everything, but don't completely shift to Python, man. If you're good at something, be good at that. Future of microcontrollers. Come on. Future of microcontrollers. Unlike us, its future is bright. I know compiler design. All right, that's great. It's very tough, and if you can build something a compiler for, between C and Python, good enough. Java and Python, JavaScript and Python, good enough. And come, if you can build something like that, please come to me. I'll share my email address. If you if you have knowledge in that, I'll give you a job. I have a significant. Yes, you know what? AI has been ruling a lot, and we are also using AI for some things. We're not able to embed AI into our controllers till now, but I hope I would be able to. By the way, every one of you listening here, if you have some idea about AI, and if you want to denoise my thing using a trained set, and if you want to give me just a small file which I can run on a controller or processor, very cheap of course, then please do connect to me. All right. Yeah, learn Python. Actually, most of the things are with Python. One thing I am very strict about in my company is whatever you do, server part has to be done in Python, Django. And everyone comes to me saying Node.js is better, and I know this better, I know that better, I don't care. And this was the same attitude of the founders of Instagram. You know that, right? Instagram was the first app that went to scale and it used Django. For me, the reason is I know Django, I know Python. If someone leaves the company in midway, I can take over it. For them, it was some interesting challenge. We engineers are like that. We'll take some challenge and we'll try to solve it. So for them, it was like this. So yeah, Python for me, Python is favorite. You can just learn Python. And what I think is if you know one language, it's very easy to shift to other languages. Just have to see how it does, how things do there. How to start in wearable technology? Companies that recruit for it. Okay. Uh, yes. First, let me see. Companies that recruit for wearable technologies are immense. If you're good at wearable, go to Siemens. Literally go to Simon, knock at their doors, and say, "I'm good at this." They'll hire you. I bet they'll hire you. Send an email to their HR. I'll give you the email address. They'll hire you. Intel, they'll hire you. Microsoft, they'll hire you. But you have to be good in wearable technologies. Everything that they are making is wearable. You won't believe when I went to Microsoft office, Microsoft in Bangalore, they have a whole room set up of sofas and beds and everything to make everything IoT. And what they're building towards is wearable IoT. So see the level of things that they're doing. And how to start in wearable technology. Microelectronics, as in electronics at small scale. Figure out BMS for small scale. Figure out networking at that scale. When I say small scale, it is small devices, memory constrained devices. I think SM32 would help. Ambiq, AMBIQ is the company's name. You can get few boards with that. That will help. I think Raspberry Pi. Come on, they made a Pico 400 something. Pico, Raspberry Pi first microcontroller. Very good, small. That's the starting of wearable technology. If you are good at that, you move towards. I think there is something called 7 rules of creating wearable tech and something. So you can go from there. If you want, I can help you definitely. Connect to me. Yeah. Right. And about recruitments, any company, any startup, any big company will recruit you if you are good enough in wearable. Because wearable is the toughest thing you can do. All right. So, Zan,
Yes, so I think that's about it. Thank you
thank
so
you.
much, sir, for being so patient with us and answering all our questions.
Okay. That's my pleasure. Thank you. Okay. Thank you. Bye bye.
Thank you, sir. Bye,
Thank you
sir.
for returning, sir. Bye.
Thank you, sir. Vit-Hackx.
It's
Now,
light.
two. No, no, he
Thank you,
is.
everyone, for being active and enthusiastic. Stay tuned to our Discord server and for more information regarding the Hackex. So, the information regarding review one will be sent to your mails and is also put up in the Discord server. So, please stay tuned and all the best, guys. Good night
All the
and
best,
see you
guys.
tomorrow.
Good night, guys.